Hello, we're going to take a look at section 4.3. In this section we'll take a look at partial derivatives. That's our first step into some real calculus. We're studying these functions of several variables. We'll start with some definitions and some notations. The definition that we'll see is pretty much the same as it was last time, except now we have two variables. And we're also going to have two partial derivatives. Now the notation will vary depending on what we're looking at. Sometimes we might see a subscript x, sometimes we might see a df dx. Although the d looks a little different. This d is a symbol called partial. This is our partial d, or partial of f with respect to x. So this is not really a Greek letter, it's just a special symbol that they started to use to describe the idea of partial derivatives. After we define this and we establish some notation, we're going to estimate partial derivatives by looking at contour curves. If you remember, contour curves are those horizontal slices of your curves, and then we're looking at it flat in a two-dimensional space. So as an example, if we take a look at that red dot, we want to estimate the derivative of that red dot with respect to x. Now, assuming x is going in the horizontal direction to the right, we can see that if you're standing in that point on the hill, that if you go to the right, or if you go, I guess that would be east, then you would be climbing up the mountain. So you would have a positive partial derivative. If you were to go north, or along the y value, a vertical value, then it looks like you're going to stay pretty flat along that mountain. We're just looking at the first step, and if you look at that first step, it looks like you're going to have a partial derivative of 0 going in the y direction. Next, we'll take a look at functions of 3 or more variables and describe the partial derivatives. Now again, the partial derivatives would be dependent on some limit as h approaching 0. But when we actually perform the partial derivatives, we're actually just going to hold the other variables constant, and then you'll take the derivative with respect to whatever variable you're taking the derivative with respect to. And then finally, we're going to take a look at higher order partial derivatives, and that would be our second order partial derivatives, kind of like the second derivative. We would be taking the derivative with respect to x first, and then you can take the derivative with respect to x again, or you can take the derivative with respect to y after you took the derivative with respect to x. So it turns out that there's two special second order partial derivatives called the mixed partial derivatives. That's if you take the derivative with respect to one variable first, and then you take the derivative with respect to the other variable second. It turns out that these two partial derivatives will be equal to each other, provided that you actually have a nice function. And that is one of the theorems that we're going to take a look at. Also, with these partial derivatives and the higher order partial derivatives, we have an idea of differential equations. When you take the derivative with respect to just one variable, we will call that an ordinary differential equation. But then if you're taking a look at or trying to solve for a function that has more than one independent variable, then you're starting to look at partial differential equations, because you're involving partial derivatives into the mix. Okay, that is the overview of section 4.3. Good luck.